Hi, I'm Emmanuel Joseph. This is how I would architect a Go project. If you've written a software solution before, chances are like few weeks into like your development cycle, you would realize that it sometimes gets difficult to introduce certain changes to your code base or introduce new features to like your existing solution. So when you have this kind of problem, it most likely means you have like bad architecture design. And in this video, I want to show you how to avoid those problems early in your development phase. Um, so what is architecture design? Architecture design is basically the careful design of the structure of your software. And a good architecture aims to make your software source code easy to navigate, easy to understand, easy to change. Basically, others on the team should be able to like understand where to look for things in your code, and also it should be easy, very easy for you to introduce certain changes into your code base if you have like a proper architecture design. So most of the ideas in this book were in this video were gotten from this book, Clean Architecture by Uncle Bob. I would advise you to read this book, and also if you could look into Clean Code, also it's also a very good book. Um, a good system architecture is, and one of the concepts of Uncle Bob in his book is this: a good system architecture is one which decisions about frameworks, databases, web servers are ancillary and deferrable. The architecture does not depend on those decisions. Good system architecture allows those decisions to be made at the latest possible moment without significant impact. Basically, what he's trying to explain there was that you should be able to make certain decisions split second without it costing you so much development time to make those changes. So some of those changes he was talking about was you being able to introduce a new framework, or when he's talking about framework, he's talking about your web framework. So for example, if it's a Go project, you're talking about your Go Echo, Go Fiber. It should be possible. If you're talking about PHP, you're talking about like say Symfony, Laravel. You should be able to like change them anytime. Um, you should be able to change your database layer at any point in time. Also, like you should be able to like swap between MongoDB and MySQL and not necessarily have to pay like make it change a lot of files in your code base. So let's get into it. So this is the features of a good architecture design. A good architecture design should be independent of frameworks. You should, like I already explained, you should be able to switch between Go Echo and Go Fiber without having to like think too much about it. A good architecture design should be testable. So testability is like the test that you have like a very good code base, or that your code base is clean. If you can unit test a code base, it means you've done a good job. Like if it's very easy to unit test your code, it means like you have a very solid code base most of the time. So make it easy for you to like write unit tests. Independent of the UI. So you should be able to switch between, like, say for example, you have like a web interface and your client says they need an API layer. You should be able to introduce that API layer without having to have a problem. You should be able to add like a console layer. You should be able to switch between GraphQL and REST APIs easily if you have a very good architecture in place. Your code should be independent of database. I already explained. You should be able to swap out between like whatever kind of database driver you want to use easily. Um, so layers in a crude application. So crude application, what do I mean by crude? Crude is like create, read, update, delete. These layers are like actually in most software solutions that you find, but I'm very particular about crude because that's most of the operations you would be handling. Um, the IO layer is how like the outside world communicates with your software. So, say for example, it could be like your web interface, like in the browser when user presses a button and sends a request to your server, and you return with a response to the user. So that could be an IO layer. Your API is an IO layer. Your console is also an IO layer. Like if you're interacting with your application from command line, that's also an IO layer. You have the business layer. This is the core part of your application. The business layer is how so it's like the business rules of your application, and it should be treated as like a black box. I will explain later. This is the core part of the application. Then we have like the data persistence layer. So this is how like your application persists data or stores state. So for example, you could store the data in your like MySQL, MongoDB, a distributed ledger, whatever data storage you find comfortable for your solution. Then external services. Your external service is how your software interacts with the outside world. So, say for example, you're consuming an API for anti-money laundering or whatever API you're consuming within your software that you don't have control over is basically your external services. So if you're like integrating Mailgun, Nexmo, SMS API, whatever API, or it could not necessarily just APIs, it could be any form of thing that you're integrating into your application that you don't have control over. Any other software that you're consuming in your application that you don't have control over. It's like usually your external services. Setting boundaries. Now, the first problem with bad architecture design is like there's no like boundaries are probably not set. You don't have like clear boundaries in your application. So setting those boundaries are like very, very important in a software. And let me show you a typical example. Here I have like a traditional handler. So back in the days when I used to write PHP, I used to use Laravel a lot. If you send a request to me, I would just have like a controller that basically does everything. So in my controller, I could have like a particular handler in the controller that just takes in like a particular input. So this is how I would have it anyways. I would just like get the input from the user. I would try and like throw an error if I couldn't get the input, but Laravel does that by default anyways. I would validate the input. If there's validation error, I would throw the validation error to the user. I would also have like this is still part of the validation process anyways. Then I'm encrypting the user password. I am creating a MongoDB instance and I'm sending it to MongoDB. I'm sending a mail to the user, welcome to our architecture design. Then I'm responding back to the user. Now, the problem with this is like I said, there is no clear boundary. And the challenge is, imagine we have like about 500 endpoints like this. You can see I have like some MySQL code some MongoDB code written here. The problem here is that if our manager comes and says, oh, we now have a deal with MySQL and we don't want to use MongoDB anymore because let's just assume MongoDB is more expensive and we're trying to cut costs, and we're like, oh, we are using MySQL, it's cheaper, it's faster, blah blah blah. Now, if we have like 500 handlers like this, it means we have to like manually start looking for everywhere we have like MongoDB written in our code base and go and start converting those queries to MySQL queries, which can be very, very cumbersome. And those are the kind of things we're trying to avoid with a clear architecture, with a better architecture. So how would we know how to set these boundaries? So like the IO layer, these are the rules around the IO layer. I already explained what the IO layer is. This layer is represented by handlers and controllers. It is tied to the framework. This is a part of the application that knows about the framework. So if, say for example, if we want to change from Fiber to Go Echo, this is the part of the code this is the only part of the code that will change. Every other part of the application is not supposed to change. It's not supposed to like touch about 500 logic to make that change. In most cases, your IO layer is not unit testable. You actually need, because it's very dependent on the framework. So you need to like use like the tools available in the framework to make tests. So usually I just write integration tests for this particular layer in my application. And yes, it depends on the business layer. I'll show you a better example later. So then we are into the business layer. So the business layer is the core of our application, is the core of our component or module, depending on how you want to say it. It is the implementation of the use case of the application. It is the implementation of the use cases the application sets out to solve, and it should be treated like a black box. The business layer should never be aware of the. Anyways, let's start. Let me explain what I just said here. So, the business layer, what I mean by use cases is that like they are like in your guide or whatever document, your user story or whatever way your administration your manager communicates like features to you. You have certain rules in those cases that in those stories that you want to be able to like achieve. So for example, in a registration feature or registration endpoint, you want the user to be able to create an account. You want the account to be secure, like you don't want anybody to be able to have access to that account. You want it to be done over like say over a web interface. Those are the use cases. Those are the rules of the application. But this should not be like. So what I mean by being treated as a black box is like you should never allow what's going on in the IO layer in the data. You should never let the business layer be aware. Like if you look at this diagram here, it's inside a box. Everything that is going on here has no reference to the IO layer or the data persistence layer or the external service layer. There's no direct reference to them. Everything is in here. No direct access. The only thing that is aware, the data persistence layer might be aware of the business layer. But the business layer should never be aware of the data persistence layer. The business layer should never be aware of the IO layer. The business layer should never be aware of the external services. Anyways, so what's inside your business layer? So in the business layer, we have the logic. The logic describes application-specific business rules. It specifies the input to be provided by the user, the output to be returned to the user, and processing steps involved in producing the output. So what I mean by application-specific rules, business rules, is that so when your manager is writing you the user story, for example, they just say register. They probably will not tell you to respond with error 404, error 402. Those are like technical jargons. So those are like application-specific rules. Like if there's a validation error, you respond to error 422. If there's so those are application-specific terminologies. What your manager is mostly cares about is I'm sending you, like, I want the user to be able to register. I want the registration process to be secure. And I want them to be able to get a mail after they've registered. Those are the business-specific rules. Then the application-specific rule is, we are like going to be encrypting the password using SHA-54. Those ones are application-specific. We are going to be sending the mail using SMTP. That's application-specific. Those are technological-related rules. So, anyways, so it specifies the input to be provided by the user, the output to be returned to the user. So now look at this traditional handler I had before. Now let's look at how I would write the same code using some of the rules the boundaries I've explained earlier. So this would be my new handler. Look at it to see how simpler it looks. And by the way, one of the problems with this handler is it doesn't follow the single responsibility principle. That is, there are multiple reasons for this class to change, and the multiple reasons are like if for example, if the MongoDB, if we decide to change from Mongo to MySQL, this class has to change. If we decide to change from Mailgun to another provider, this class has to change. If we decide to stop using this current validator we are using, and we want to change the validator to another kind of validator, this specific class has to change. So if you decide to change from Fiber to Go Echo, this class has to change. So it breaks the single responsibility principle. Bringing it back to our new distance. So if you look at our register endpoint, we have like, so what your controller or your handler is just supposed to do is just send in input, get output. You should not worry about how the user is being registered or whatever goes on on that end. That's the job of your business layer, your logic. So the same thing happens here. So I'm just getting the user input, I'm passing it to our business layer, which is just one line now, and I'm getting the response, and I'm presenting that in a way that is convenient for our framework. So this one is an API, so we are responding in JSON. If it was supposed to be like an HTML, so we'll be responding with an HTML page. I hope that makes sense. Then in our logic, you can now see that here is where the actual work is being done. But if you look at the logic itself, we don't know anything about the outside world, which means that we don't know if this is like an API or if the response we are getting, if the input is coming from an API. We don't care, we don't need to know, because that's an IO layer. It should be separated, so that boundary is clear, cut off. So we don't need to know. What we just know is like we need a user input. So we have like a user data, which this is a DTO. I will explain what a DTO is later. We are getting that input, and we are responding with another DTO, which is the user, like the registered user data. So we are responding that, and we are throwing an event. So your logic should not know anything about the outside world, which I've already explained. Your logic should depend on abstractions and never concretion. Now, what that means is that your logic in itself should never depend directly on, say, for example, the database layer that you're using. So you cannot see any reference to MySQL or MongoDB here. You cannot see any reference to HTTP or how we are getting the input here. So your logic should be independent of those things. You should never know, you should never be aware. So your logic is like your God class in this architecture. So every other thing depends on the logic. The logic doesn't know anything about the outside world. So it's a black box in that sense. So we are just sending in an event, and we said, so now it should depend on abstractions. What do I mean by abstraction is everything that is injected into the logic is passed through an interface that we created inside of the logic. So we have like the user store interface, we have the event interface, we have the validator interface. So this is also an interface in this our black box. So if you look at it, we don't have any direct reference to any concrete class here. We only have like interfaces. So that what the advantage this gives us is, number one, our code is like very testable, because we can swap out any layer of the application at any point in time, because we don't have any concrete dependencies on them. So we just know that we have like a user repository. This is supposed to be like how we are saving data into so if you look at our traditional handler, to create a new user, we need one of the business rules. To create a new user, we need to know if the email or phone number does not exist. If the email or phone number exists, it means we are going to throw an error that, oh, this user already exists in our database, and we need to save the user. So these two has been collapsed into this interface. These two has been collapsed into this interface. That's the store user and email or exist interface. So we don't know how the database layer is handling this situation. What we just know is we are telling it, if I give you an email and a password and a phone number, check for me and tell me if those things exist, and I will do whatever I want with that information. Then, or I'm sending you a user data, create that user data for me and give me like the response from the database. So those two things. Then we have the last rule of the logic in the business layer. Changes in the outside world, in your framework, in your database, or any external service should not. So the changes in the outside world should not affect your. So the fact that we change our database should not lead to changes in if our business rules does not change, if our application specific rules does not change, we should not have to like come and change anything in our logic. Say for example, if our manager later comes to us and says, "Oh, we can have multiple like a user can have multiple accounts, like an email can belong to multiple users at the same time." It means email is no longer unique to a user. It means our business rules has changed. Then we can come and change some codes here. But if the business rule or the application's rules do not change, like if the business rule do not change, for example, there's no point for us to change anything in this code. So if, for example, what our manager just says is, "Oh, we need to introduce API to our application," the business will have not changed. It's just like the only change that happened was that we don't want to use we don't want to use like a web interface anymore. We want to use an API interface. So if that's the only change that is happening, then nothing should change in this class. The only part that should change is our handler. And if, for example, tomorrow comes and it says, "Oh, we want to switch from MySQL to MongoDB," nothing should still change here. The only part that should change is our database data persistence layer, which is like the actual MongoDB that stores the user. Anyways, so data persistence layer. This layer deals with storing and retrieving data for later use. You should at any point be able to swap out this layer without having to change anything in your business layer. So I already explained what the data persistence layer is, but the major thing here is like the interface adapter. So the interface adapter, the classes here are a set of adapters that convert data from the format most convenient from the business layer to the format most convenient for the database driver. So this interface adapter is how our we can introduce changes to like the database layer and not care about our logic. So for example, like I said, the logic depends on interfaces. The data layer depends on adapters so this is how I will look at it. We have our repository, we have the MongoDB repository. So if you look at the MongoDB repository, we have like the store user and the email or phone number exists. You can see that this is like the interfaces, like it's trying to satisfy this particular interface in our code base, like store user and email or phone number exists. So that means that like whatever it is we are doing here, this is where we now introduce like our MongoDB code. So we are just taking, so in our, what's convenient for our logic is email as string, phone as string, right? So then we have like my MongoDB code here. We do the check for it, and what the response that's convenient for it is it needs a boolean to know. So we are just passing in a boolean or throwing an error if there is one, right? Then basically that's it. Then see, for example, the store user. In the store user, we are taking the data that the user sent, which is like the DTO that was sent from the user, which is in like, this is the structure of that DTO, and we are converting it to DTO that is like convenient for our data layer, which is if you see, I'm creating a new Mongo data, which takes that user data, convert it to a structure convenient for us. So this is now like BSON, that if you're familiar with MongoDB structure, and we are sending it to, we're sending it to like you can see, saving it, insert, decoding it back, Then when we take the response from the database itself, we then convert it back to a layer, like a data structure that is convenient for our logic. And you look at it, then we are saving the data back. So then we are returning back user data to the user structure that is convenient for it, because it dictates the terms here. And this is what we send back to our handler, to the user, and that is what's converted to like a story here, like to the response to the user. So external services is almost the same thing too. It's like how we like interact with the external world. So it's basically the same adapter approach that we have for our MongoDB. That's the same thing. You just have like an adapter that you convert what's comfortable for our logic to. I will be recording another video soon, modular monolithic architecture. But I wanted you guys to see what I have here. And yes, before I forget, the other important part here is like, you might think that yes, this is like a lot stressful, but trust me, it will save you a lot of time later. If you have a code that you're not sure if certain things might change, if you're very confident that your code will not change, you don't need to like follow this architecture, because if you're not changing anything, if the code will remain the same for years to come, there's no point. You can use the traditional approach. But if you're working for like an organization where like certain rules always change, and you don't want to go through that straight, especially if it's like a large scale application that you're building, it's best to go this route, actually building like this. So then I also wanted to demonstrate the testability of our code. So if you look at our logic, this is the part where like I am unit testing, like, so we have like test user registration. You can see I'm mocking so I'm getting like a mock of the of the user repository. You can see I'm mocking the repository. I'm saying like anytime like email or phone number exists, and I'm passing in that mock to our user logic. So I'm passing the mock, I'm passing the validator, and the event mock. And I'm sending that into this logic, and I'm saying, oh, where I'm trying to register, and I'm seeing that so basically my code is like unit testable. I don't necessarily have to like test this thing over the internet. I can test this thing anytime without the internet. Unlike this particular class, this particular method, I want you to look at it and see how you can test this code without having to like depend on like the internet to test it, because your Mongo layer most likely is over the internet, or like you're connecting to like it locally and all of those things. So that's a problem. So but this, on the other hand, you can like easily test your logic at any point in time. I can be I can be on a plane and test this logic part. I can introduce new features to this logic part, and I will be able to test it easily. And I have my integration test here, and this is where I test like the full like application from the like an end-to-end test, except that here I am actually switching from MongoDB. If you look at my repository here, I'm using new map. If you look at my repository here, I'm using Mongo repository. So, and I can make that change easily without having to like rewrite my code. Anyway, I just wrote like a map interface, a map adapter, sorry, for the same interface, which have like store user email or phone number already exists, and I can just do that test easy. Then last thing I want us to demonstrate is the orchestrator. So the orchestrator is how like my system ties everything together. So if you look at here, I'm saying boot the user module, with Mongo and Fiber, which means here I want to pass in the Mongo repository. So if you look at the user handler, I'm passing in the Mongo repository, make user logic. So this is my logic here. I'm passing in the Mongo repository, I'm passing in the validator, and I'm passing in the event to it. So, and that logic is what I then pass to my handler, and I'm registering the routes to it. So I'm adding like the fiber to it. So which is where I registered like the route. So if you remember the logic, this is the logic I passed in, which contains like the Mongo repository concretion and all of that. And I do the register here. So I'll be pushing this code on GitHub. You can read through the code base itself and understand it. And if you have any question, you can drop comments on the video. I hope I was able to like explain. And if you have questions, I'll basically answer them for you. So thank you very much for your time. Bye.